Hey guys, we're going to be talking about solving a system of equations algebraically with a line and a parabola or a line and a circle today. All right. So remember, a system of equations is two or more equations. We did actually a system of three equations all the way back in the beginning of the year with that x, y, and z, but those were all linear. All right. We haven't really done too much with a line and a parabola algebraically, okay, or graphically, really. Okay, and same with a circle since we just learned it. So it says algebraically, guys, the solution to the system is the value of each variable, that's key, each variable, that makes each equation of the system true. Meaning that if you subbed in the x and the y that you found, the left side should equal the right side for each equation. Okay? Graphically, the solution to the system is the coordinates of the point where the two equations intersect. All right. In fact, we did a system graphically with a circle and a line the other day, and the answer was the 2 points of intersection. And so we're going to find those points of intersection, but without a graph. Okay, we're going to do them all algebraically. So we got to really make sure that we pay attention to detail and that we don't make any mathematical mistakes, okay, when we combine like terms or factor and stuff like that. Otherwise, things won't work out how they're supposed to. All right. We are going to go ahead and use what we call substitution, all right, for these. We cannot use elimination like we used in the beginning of the year with our system of three equations, okay? We have to use substitution. So what we're going to do is we're going to get one of our equations either into y equals form or x equals form, okay? And then we're going to take that y equals and we're going to take what it equals and put it in for the other y in the other equation, okay? Couple things to be careful about. If you have a negative in front of the y that you're substituting in, you're going to have to make sure that you distribute that negative to everything you put after it. Okay. For instance, it's going to happen in this first one. Okay. And again, there are multiple different ways of doing this first step of substitution. For instance, I can get the second equation into y equals and then put it into y from the first one. Or because this is already y equals, I can take what it equals, take this y out and put it in, but I have to be careful with that minus sign right there. Okay, so here we go. I'm going to now rewrite the second equation, and it's going to say 3x. That minus is there. Because I'm substituting in, I should always 100% of the time use parentheses around what is going in, okay? And then I have the equals 1. All right, so I just rewrote the second equation, but I substituted the y out, and I put in what the y equaled from the first equation, and that's called substitution. All right, so now we're going to go ahead and take 3x and keep it. This is going to become a minus 2x squared. This is going to become a plus 4x, and this is going to become a plus 5 equals 1. Okay? Because we have a squared term, chances are we're going to have to factor, but we can't get factor unless we're equal to 0. And remember that if we are going to factor, okay, we want to try our hardest to make our squared term a positive, okay, leading coefficient. All right, so I'm going to just clean this up a little bit. I have a 3x here and a 4x, so this is going to stay at minus 2x squared. Then the plus 7x I get from combining, then my plus 5, and then my equals 1. Okay, and what I'm going to do now is I'm going to make all these terms go to the other side so that over here, it'll now be positive. Okay, remember to move each term with the opposite operation. And now all my terms are gone from this side. On that side, I have a positive 2x squared, a minus 7x, and I had the 1 here minus the 5, which is a negative 4, equal to 0. Okay, and now that I'm at this point, I'm going to hopefully try to factor. Remember, if factoring doesn't work, we have completing the square, which we're not a huge fan of. Okay? It is an involved process that is hard to remember. Or we have quadratic formula. Okay? I will tell you that our solutions to our systems, though, should come out to be rational answers for our x values so that we can plug in those nice answers and get nice y values and nice points of intersection. Okay, so chances are if it's not factorable, check and double check to make sure that you didn't make a mistake. Okay, all right, so we cannot pull a 2 out to get rid of our hard trinomial here. So we'll put the sad face to remind ourselves that we got a little bit more work to do. Our multiply at the top is -8, and our add at the bottom is -7. And we're going to find the numbers that do the job to be 8 and 1, except our 8 has to be negative. Okay. And now we're going to go over here. Remember that it's a hard trinomial and factor it by rewriting our trinomial so it has 4 terms. So we got 2x squared minus 8x plus 1x minus 4 equals 0. We'll group the first two, group the last two. And out of the first group, we can pull out 2x. Left over will be x minus 4. And out of the second one, we have to pull out something, and it's going to be a positive 1. And left over is x minus 4 equals 0. Okay. One of our factors is x minus 4. And our second factor is 2x plus 1 equal to 0. Okay. We'll do a little t-chart. And on this side, we're going to end up with x equals positive 4. And on this side, we're going to have to subtract the 1. So our 1 will become negative, and then we'll have to divide by 2. Okay. And now we'll just go down because we're not finished. A lot of people will stop here and they're going to lose 1 to 2 points because they didn't finish solving the whole system of equations. Remember, a system of equations has 2 variables in it, x and y. Just like in the beginning of the year, we had 3 variables, x, y, and z. We had to solve for all of them. These are no different, okay? Just a little bit nicer because you only have 2 variables instead of 3. Also remember that a solution to the system is a point of intersection, and all points have an x and a y, okay? So make sure that you find the y's. All right, so what we're going to do is we're going to go back to the top, and we're going to choose one of our equations, okay? I'm going to go ahead and choose the second one, okay? I recommend not choosing the equation with the squared terms in it, always choosing the equation without the squared terms, which is our linear equation. So I'm going to go ahead and rewrite it. So it says 3x minus y equals 1. And now that my x is 4, I'm going to go ahead and substitute my x out and put in my 4. Remember, you should always use parentheses when you're substituting in, okay? And so that's going to become 12 minus y equals 1. Okay, you got a couple options here. You can either add 1 or add y. I'm sorry, subtract 1 or add y. I chose to add y. All right, and then I'll subtract my 1 over. So I get 12 equals y plus 1. We'll subtract the 1, and we end up with y equals 11. And so now what we're going to do is we're going to take the x that we substituted in and the y that we got as the result, and we're going to write it as a point. X coordinate comes first, then the y coordinate, and there is one of the points of our intersection. Okay, we're going to take the same equation, 3x minus y equals 1, and we're going to take out the x and put in negative 1/2. Okay, 3 times negative 1/2, we get is negative 1.5 minus y equals 1. Okay, we can add the y over to this side and subtract the 1 over to this side. Okay, if we could do that all at one step, we end up with negative 2.5 equal to y. And so now we're going to take the x and pair it with our y and get our second point of intersection, which is negative 1/2 comma negative 2.5. And it doesn't matter if you give them as fractions or decimals, they're equivalent to each other. Okay. And there's the points of intersection. If we graph this parabola and we graph this line, that is the 2 points where they would intersect each other. Okay, and we could do it without a graph. All right, so let's go ahead and try another one. Number 2. This is a circle at the top with a center at 0, 0. Okay, I can tell that it's a circle because both the x and the y are squared. Okay, or some people will say it has 2 squared terms in it. And the second equation is a line because nothing is squared. All right, again, we're going to use substitution. What's nice about this one is that the second equation is already into y equals form. And so we're going to take what y equals, and we're going to drag it up into this equation, and we're going to replace that y with it. Okay, common mistake is that you'll replace the y squared with it, but remember that it's only y equals x minus 28, not y squared equals x minus 28. And so that squared term has to stay there, okay? And so now I'm going to just rewrite it. So it's going to stay x squared plus, okay, remember you're substituting, so you should use parentheses around the x minus 28 because that's what you're putting in. And don't forget the square is still there, equals 400. Okay. All right, so next thing up is that x minus 28 squared really means x minus 28 times itself. So we're going to go ahead and expand it out, unsquare it. and we're going to put it together, okay? At this point, if you are a box person, okay, you might want to put it together in the box, or you can put it together right here. It does not matter, okay? And so we got x squared stays plus, and now when we put this together, we're going to get another x squared. The outer is going to be a minus 28x, but the inner is going to be a minus 28x also, and so you're going to get a minus 56x. Okay, and then the last one, a negative times a negative is a positive. 28 times 28 is 784 equal to 400. Okay, now we're going to go ahead and do some cleanup. An x squared plus an x squared is 2x squared minus 56x. And we're going to go ahead and subtract this 400 over at the same time. If you can't handle that 2 steps in at the same time, you can always do it in 2. Okay, plus 384 equals 0. But I know I have a square term over in the front here, and I know I have to be equal to 0 in the back. All right, so that's why I brought that 400 over. All right, so we're going to try to get out of this hard trinomial because if you notice, all of our terms are divisible by 2. And so we're going to pull that 2 out. And we'll be left with x squared minus 28x plus 192 equals 0. And now I have a nice, easy trinomial to factor. So I'm going to set up my x box. My multiply is 192, and my add is negative 28. Might take you a minute or two to find the numbers, all right? But try to use the table in your calculator. 192 divided by x is what you type into y equals. And then you can scan through all the numbers that multiply to 192. Okay? And eventually you're going to stumble upon 16 and 12. And you're going to make them both negative so that they multiply to a positive 192 and that they add to a negative 28. Okay? This 2 is just going to hang out here. It is an easy trinomial. Okay, we could have gave him a happy face. All right, and that means that we can go right to our factors of x minus 16 and x minus 12 equal to 0. Okay? We can no longer factor, and so now we're going to go ahead and set up our our t-chart. And this 2 is going to get equal to 0, but you're not going to get any solutions because there's no value of x in that factor. But this factor has an x, and so we're going to get x equals positive 16. And this factor also has an x, and we're going to get x equals 12. Okay? Remember not to stop here, though. Okay? When you have all this algebra, you're going to keep going with your algebra because don't forget you have to also solve for y. Okay? So we make this an extended t-chart. Okay? And we're going to go back up to the top and grab the linear equation, which is y equals x minus 28. We're going to use it on both sides. Okay? On this side, the x is going to come out and 16 is going to go in. And we're going to end up with y equals 16 minus 28, which is negative 12. Okay? And we're going to go back up and we're going to grab our x and pair it with our y and write it as a point of intersection, which would be x coordinate first, 16, comma, negative 12. Okay. On the other side, this x is coming out, that 12 is going in, and we end up with y equals 12 minus 28, and so we end up with y equals negative 16. We're going to grab the x, pair it with the y, and our point of intersection is 12, comma, negative 16. And there are the 2 points of intersections that this circle and line would have if we graph them. Okay. All right, so let's take a look, guys, at what we have down here in number 3 and number 4. When they ask you multiple choice questions based on solutions of 2 equations, okay, we can 100% use our calculator, but we do have to know how to use our calculator in order to figure that out, all right? So in number 3, it says, which value to the nearest tenth is not a solution of p of x equaling q of x? When they say one equation equals the other one, they're saying intersection. Intersection. Okay. They want to know when will one equation equal the other? When they have the same variables, and having the same variables is their intersection or their solution to the system of equations. Okay. So here's one of our equations. And here is our second equation. And what we're going to do is we're going to go to y equals. Okay. In the first one, we're going to go ahead and put in the p of x equation. So we can put this in y1 in our calculator. Type carefully, okay, make sure everything's there. And in y2, we're going to go ahead and put the q of x equation, which is 3x plus 8. Okay, and we're going to hit graph. When you hit graph, you do see for the most part a lot of the two equations. However, if you can see the first intersection point, you can see the second intersection point. What you have to use is your brain and realize that there is a third intersection point that you cannot see. So I'm just going to quickly sketch, guys, what I see on my calculator. Hopefully you took the time to graph it so you can do it on yours as well. But the first equation is called a cubic. It goes up, it comes down, it turns around again and goes back up. Okay, the second equation is a line, and down here in the third quadrant is the first time that they intersect. And then in the second quadrant, they intersect again. And then what happens, it continues on, and there is going to be a third intersection up here. You just can't see that on your calculator. So because it's up here, we're going to go ahead and we're going to press our window, and we're going to change our Y max so we can see a little bit more of the top, okay? So hit your window button, which is next to your Y equals, and scroll down till you see Y max. And let's go ahead and change it to maybe, let's say 20. We'll go back to our graph, and we're going to see if we can see it a little bit better. We have to wait for it to graph. And there it is. Now I can see all three intersection points, okay? So it says which value to the nearest tenth is not a solution, okay? Remember, solutions are what x equals, okay? So we want to know which one of these is not. So we're going to go ahead and find these three intersection points using our calculator. There is an intersection command. What you have to do is you have to go to second, trace. That's your calculate menu, and number 5 is intersect. And we want to go to that command, okay? So hit the 5 or scroll down to 5 and hit enter. What you now have is a little cursor on your screen, and we're going to go and move it to the first intersection point, which is on the left, okay? As soon as your cursor is close to it, all you're going to do is hit enter 3 times, okay? Enter, 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 okay? I didn't move my cursor at all. All right, once it was on this intersection spot. And right at the bottom, after hitting enter 3 times, it's going to tell you the point of intersection. And this one is negative 3.942 dot, 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 comma, negative 3.8 dot, dot, dot. Again, because they're talking about solutions, we actually don't really care about the y. We just want to talk about the x. And so if you look at your choices, they're all rounded to the nearest tenth, and the question says nearest tenth. And so this is going to be negative 3.9. Okay, and that is a solution. They're looking for which one is not a solution. So choice 1's gone. Okay. All right, so now I'm going to go ahead and go do this all again. So I'm going to hit second, trace. So I go back to my calculate menu. I'm going to go down to number 5, which is intersect. The calculator screen gives me the cursor again, and this time I'm going to move it to the second intersection point. Okay. As soon as the cursor is close to it, you're going to hit enter 3 times. 1, 2, 3. Okay, and it's going to spit you out an answer. Okay, and the coordinates of this point is negative 1.111 dot, 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 comma, 4.66 dot, dot, dot. Again, because this question is talking about solutions, which is what x equals, we don't really care about the y value. And so this is going to round to negative 1.1, which is choice 2. But again, remember, they're looking for which one's not a solution. Okay, all right, so we're going to do it all over again. So second trace. We're going to go back down to intersect, which is number 5. We're going to move our cursor to the third intersection point. As soon as it is close enough, we're going to hit enter 1, 2, 3 times. Okay? And this point is going to be at 2.054 dot, 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 comma, 14.16 dot, dot, dot. Again, because this is talking about solutions, which is what x equals, we do not need the y value. And this would round to 2.5 would round that 0 to a 1, 2.1. And again, they're looking for which one's not a solution. And so now we have our answer. All right. The other 3, we clearly could see our x values. Number 4 is not. Okay. All right. So that took a little bit of time, but not terrible. Okay. Number 4, it says how many solutions exist? And right here, they write this equation, or this question a little bit differently. So what we have to realize is that it's an equation equal to equation. And when that happens, they're talking about the intersection of them, okay? And so in y1, we're going to go ahead and put in 1 over 1 minus x squared. And in y2, we're going to go ahead and put in negative absolute value of 3x minus 2 plus 5, okay? So we're going to go back to y equals, and we're going to go ahead and clear those equations out, okay? In y1, we're going to type in 1 divided by, and this is going to be a little bit tricky. We have to make sure that there are parentheses around that denominator because that bottom has not been cleaned up to be one term down there, okay? Or if you have the fancy fraction button, you can use the fraction button where you can see that that 1 minus x squared is in the denominator, okay? Otherwise, use parentheses around it. We're going to hop down to y2, and we're going to hit the negative button first, and then we're going to go get our absolute value. So if you remember, second 0 is our catalog, and ABS, absolute value, is the very first thing. Type in 3x minus 2. Hop out of the absolute value bars and hit plus 5. Okay? Now that I have both of my equations in here, I'm going to go ahead and hit my graph. And in my calculator screen, I see all of my intersection points. Okay, so the first graph kind of looks real funky, and it does a bunch of jumping around like this because the denominator. And in the denominator, remember that you can't divide by 0, so there are 2 values in there where you can't be, and so that's why it jumps around. There's vertical asymptotes there that you can't see. Okay, and then the second equation hits the first equation once, twice, 3 times, and then a 4th time. So it hits here, 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 and here. Okay. And so in this question, they said, how many solutions exist? Oh, well, this one's a lot easier. We don't even have to figure out what the x values are exactly. We just need to know that there's going to be 4 of them. Okay, so solutions, again, are what x equals, and you would have an x value for each one of the intersection points, and so choice 4. So that was a little bit easier than the last one. Okay, all right, guys, I'll see you guys on the back side of notes.